In this video, I'll be showing you how to get the nth root of a complex number. Alright, now let's look at the question here. I'll be using this question to teach you how you can find the nth root of a complex number. Now the question here says, show that z equal to 1 plus I and z equal to 1 minus I are both roots of z to the power 4 plus 4 equal to 0, and hence write down the four roots of the equation. Alright, so how do we solve this? Now recall that in our previous class, solution for this question, Now recall that in our previous class, we talked about the concept of complex numbers, and we said complex numbers can be arranged in polar form. We talked about the polar form of a complex number as being equal to, we used r, then we said this is equal to cos of theta plus I sine theta. And we said this is the polar form of writing a complex number. Now, we would need this concept in finding the nth root of a complex number. But before then, here's your formula to calculate the nth root of a complex number, okay? So we can say the nth root of a complex number is given by the formula z to the power k. It's equal to r to the power 1 all over n, okay? Then into this becomes cos, so cosine of pi plus 2k pi all divided by n, so n plus I into sine. So I'm following this, so cos, now theta becomes this, all right, that's it. So I'm following the same order there, plus I, which is this, then obviously my next thing will be what there, sine, all right? So I'm bringing sine down, so this into sine. Now theta becomes pi plus 2k pi all divided by n, so this all over n. Now here's the formula you use in calculating the nth root of a complex number. Okay, this is the formula. Now what does each thing represent? Let's start with k. Now k is simply numbers starting from 0, 1, 2, 3, 4, 5, and ranges up to n minus 1. All right, so k starts from 0 and ends at n minus 1. Now, what exactly is n? N is equal to the number of roots required. All right, that's n. The number of roots required. So n is the number of roots required. All right. Now, if I look at the question here, the question says, write down the four roots. You can see it here, four roots. Right? If it says 4 roots, that means in this case n is equal to 4. Right? So for this question here, n is equal to 4. So if n is equal to 4, because we're asked to find the 4 roots. Now what will k be? K will be equal to 0, 1. We said k will end at where? N minus 1. So if n is 4, that means k will end at n minus 1, and that's equal to 4 minus 1, and that's equal to 3. That means k will end at 3. So I'll start from 0 and I'll end at 3. That's the concept. In essence, this is equal to 0, 1, 2, and 3. So in this question, k is equal to 0, 1, 2, and 3. All right, so we have this. Now, next up, note that also in this concept, the value of pi is equal to 180. All right, that's the value of pi in this question here, 180 degrees. It's a constant we use for this particular part of complex number, okay? Always 180 degrees. All right, what's next to define there? We've defined k, we've defined n, we've defined pi, we've defined everything here except r. So what exactly is r? Now r, as we know, is called the modulus, all right? It's the modulus of the complex number. That's what r represents. Now recall that we said, okay, before then, coming back to the question, we're given that z is equal to, so we're given the question that z raised to the power 4 plus 4 is equal to 0. And from here, if we solve this, we'll have that z to the power 4 is equal to, move plus 4 over here, the sign changes and it becomes a minus 4. So from here, we can say that z is equal to the fourth root, that's this, the fourth root, of course, of minus 4. Or we can say that z, again, writing this in index form, z is equal to minus 4 raised to the power what there? 1 over 4. This and fourth root are the same thing. I am taking the fourth root because z is raised to the power what there? 4. That's the concept here. Alright, now to get r, recall that we said in our previous class, we treated complex number. We said if I'm given z as equal to a plus ib, that r, called the modulus, is equal to the square root of a squared plus b squared. That was the concept. Now, in the case where z is now equal to 1 over 4, what will r be? R will be equal to, observe that there's no item here. So I'm going to use just the number I have here, which is what there? Minus 4. Alright, so r will be equal to the square root of, in brackets, minus 4 all squared. That's the concept, okay? It's supposed to be a squared plus b squared, where b is the term attached to what there? I. But since there's no item here, I will ignore b. Right? This a squared is actually more like saying you're taking the square, you put a in bracket, of course. So when I say a squared, what we actually mean is in bracket a squared. So that if it is a negative term, as you can see here, it becomes positive. This is equal to this of, now open a bracket, type minus 4, close the bracket and type square, you have 16, not minus 16. It will be positive 16. If I take the root of 16, it gives you what there? 4. So r has to be a positive term, right? Don't forget, please. R has to be a positive term. So in this case here, r is equal to 4. So modulus is equal to 4. So we have this. Now with all of this set now, let's go into finding the roots of this equation. Now looking at this is z to the power k, or z base k, alright? Now we said k starts from 0 up to, in this question, we'll take 0, 1, 2, 3. So let's start with the first one there, z k. Let's find the first root. So for the roots, let's start with this. For the roots, what do we have? We have z to k when k is equal to 0. Okay, look at this. We have z and then k. Okay, let's take it this way. Let's say at k equal to 0. Alright, for the roots, let's say at k equal to 0. This will give you your first root. Alright, this is how you get your first root. So for the first root, k is equal to 0. And what would this be? Would have that z and then k, which is 0. It's equal to, look at what you have here, r to the power n. Look at this, r to the power 1 over n. That becomes r. What's r there? R is 4. So it becomes 4 to the power 1 over n. What's n again? If you look at the question here, we said n is equal to what? 4. Right? Because we asked to find the fourth root, n is 4. If you ask to find the sixth root, n will be 6. Just like that, okay? So 4 to the power 1 over 4, that's this. What's next in there you have? This, the next thing you have there is cos of this. So you open this bracket here. Let me just make a round bracket. So you have cos, cosine of what exactly? So it becomes cos of pi plus 2k pi. K in this case is equal to what there? 0. And n is what there? N is 4. So let's put that there. Becomes this into pi plus 2k. What's k in this case? K is 0, as we said. Okay, you can see it here, k is equal to 0. So this into 0 and then pi. So we have pi all over n. What's n there? N is 4 plus I sine, it's sine of the same thing, like the same thing here. That becomes pi plus 2 into k, 0, pi all over 4. We have this. All right, let's solve this question here. This will be equal to, now take your calculator, punch 4 raised to the power 1 over 4. This will give you your answer as root 2. All right, so you can get your calculator and punch that. 4 raised to the power 1 over 4. Please use a scientific calculator, a Casio calculator. You have your answer as root 2. That's for the first one there. Next up, proceeding, you now have the next in there, cos, that's cosine. You have cos. What's the next thing you have there? You have this as, let's simplify this. Now, first things first, this gives you, if you look at this part here, that becomes 2 times 0 times pi. Of course, 2 times 0 gives you 0. 0 times pi gives you 0. Okay, anything times 0 gives you 0. Now, this becomes pi plus 0. That's what you have there. Pi plus 0 gives you what there? Pi all over, of course, all over 4. So if you simplify the numerator, you have pi, then all over denominator, which is what? 4. All right. So you now have this as cos pi all over 4 plus I sine pi all over 4. You have this. Let's simplify further. This is equal to, okay, the same thing happens here, by the way. All right. So whatever thing you get here also happens here. That's the concept here. So this is simply 2 times 0, which is 0. 0 times pi, which is 0. So all of this here becomes 0. So I'm now having pi plus 0, and that gives you pi. Pi plus 0 is pi, but pi times 0 is 0. Okay, so get it right. So it becomes pi all over 4. So you're having sine pi over 4. And that's how I get this answer here, okay? So sine pi over 4, that's the concept. All right, proceeding. I'm having this as root 2. This into cos. We set pi here. Check. I said pi is equal to 180. So I'm having cos pi. I said earlier is what there? 180 all over 4. Then plus I. So plus I sine pi over 4. Pi is what there? 180 all over 4. Let's proceed with this. This is equal to root 2 into, now you get your calculator and you punch cos 180 over 4. If you punch cos 180 over 4, okay, so punch it this way. You punch cos, open a bracket, type 180 over 4 like this. If you punch this correctly with a scientific calculator, your answer will give you root 2 over 2. That's your answer. All right, so you can punch this correctly and you see your answer will give you root 2 over 2. So that's into this one here gives us root 2 over 2. So I'm having root 2 all over 2 plus, I'm having next in there plus I. So I'm having plus I into, now punch this one here. Please punch correctly. Sine, open a bracket, type 180 over 4. Close the bracket like this. If you punch this correctly, this will also give you root 2 over 2. Please use a scientific calculator and punch correctly. You have this. All right. So this value is also equal to root 2 all over 2. So I have this. My last task now is to use root 2 to multiply this. Recall that in sod, if I have root a times root a, this will be equal to what there? A. That's your final answer. How is it a? It becomes root a times a is a squared. So root cancels the squared and that gives you a. So if I have root of the same number multiplying, it will give you that number. So what does that mean? It means that root 2 times root 2 is equal to, it's equal to 2. That's what it means. Now, if that's true, what do I have here? If I use root 2 to multiply 2, it becomes root 2 times root 2 here. That gives you 2 all over what I have here, which is 2, plus, proceeding, I have I, which is this one here, into, I'm still going to use this root 2. Of course, it's outside the bracket, so I'll use it to multiply this again. So root 2 times root 2 also gives you 2 all over 2. And that's equal to, this gives you 2 cancels 2. What do you have there? 1. So I have this as 1 plus 2 cancels 2. You have what there? 1. I times 1. So it becomes I into 1. So multiply this. What do you have there? This becomes I. This becomes 1 plus I times 1 is I. So the first root there is 1 plus I. So that's the first thing there. Let's go and get the second root. Okay. We'll follow the same pattern for the first root at k equal to 0. For second root at k equal to 1. This gives you what there? Second root. I'll get my second root from this. So let's get second root here. For the second root, we have that z1, okay, and that's equal to r, 4 to power 1 over n, 1 over 4, into cos, all right, pi plus 2k. Now, for the second root, what's k there? K is 1. So please take note. So it becomes 2 times 1 and then pi all over n. What's n here? 4. Okay, plus, now look up, they were still following this same thing here, plus I sine what's there? Sine pi plus 2 into k. K in this case is 1, and then pi all over 4. So the simple concept for this particular solving is that whatever thing you have here, you also have here too, right? Whatever thing you have at this position here, you have exactly the same thing here. All right, it's just the cos and sine that you change, but they remain the same. So in essence, if you get the first part, which is this, just transfer your result here, and that's all. All right, let's solve this. This is equal to, again, we've already punched this in the first part, 4 to power 1 over 4, and our answer was root 2. So you have this as root 2 into, from here it becomes cos. So open a bracket, type in cosine. So cos into, now what do I have here? Let's try to solve this. This is pi plus 2 times 1 is 2. 2 times pi is 2 pi. So everything you have here is 2 pi. 2 pi, so okay, let me write this as 2 pi. So this becomes pi plus 2 pi. Pi plus 2 pi gives you what there? 3 pi. So numerator there is what? 3 pi. Alright, if numerator is 3 pi, we now have this as 3 pi all over, denominator is 4. So it becomes cos 3 pi over 4. Alright, so I'll just bring that down. So this into cos 3 pi all over 4. We have this. Proceeding, I have plus I. So I'm having plus I sine, of course, we said we have the same answer here, so don't stress. Just come here and write 3 pi all over 4. You have this. Now proceeding, this is equal to root 2 into, I have this as cos, what's pi? We said pi is what there? 180. So it becomes 3 times pi. That's 3 times 180. Alright, so it becomes cos 3 times 180. 3 times 180 is 3 pi all over 4. We have this plus I. So plus I sine. Again, we said we have the same thing here. So don't stress. That becomes 3 pi, 3 times 180. Close the bracket all over 4. So you have this. Alright, let's solve this again. Of course, we should have used a square bracket. Okay, I've used a square bracket here because you already have a round bracket inside. But okay, still. Alright, so let me use square bracket here. So what do you have? This is equal to root 2 into, let's punch this. This becomes cos. So I'll open the bracket there. I'll write cos 3 times 180, then divided by 4. What do you have? I'll just get, this 3 times 180. Let me get my calculator. All divided by 4. And what you have there is 135. So cos 135 plus I into the same thing here, sine. We said we have the same thing there. That's 135. You have this. Alright, let's get this value. What do you have there? This becomes root 2 into type cos 135. What do you have? If you punch cos 135, you have an answer there. Put it in fraction form. Your answer becomes minus root 2 all over 2. That's what you have. Okay? Plus I, that becomes I sine I. If you punch sine 135, your answer becomes root 2 over 2. A positive one there. Root 2 all over 2. And that's equal to, let's solve this. First things first, we said root 2 times root 2 gives you what there? 2. So I have this as minus 2. Alright? So what I have there is actually minus 2 all over denominator there, 2. In which this cancels this, and I have that as what there? Minus 1. This is 1, so minus 1. Plus I into, from here, root 2 times root 2 gives you what there? 2 all over denominator, that's 2. This cancels this, you have what there? 1. So I have 1 here. Alright? Alright, let's write this down. So this is equal to minus 1 plus I times 1 is I. So I have this. So this is my second root. So we've gotten 2 roots. We still have 2 more roots to find. Alright, the next one there. For the next one, we'll say at k. So for the next one, we'll say at k equal to 2. Now this will give us what there? Our third. This gives us our third root. Now this gives us our third root. Okay. So how do you find this? Of course, this becomes z2, it's equal to r, which is 4 to power 1 over 4 into cosine of pi plus 2k. K in this case is now 2. So this and then pi all over 4. You have this. So this plus I sine. We said just repeat the same thing here. Don't stress. That becomes pi plus 2 into 2 pi all over 4. So just repeat this, okay? Don't stress. Just repeat it. All right. This cover the bracket. So close the bracket, and that's equal to. We said if you punch 4 to the power 1 over 4, that gives you root 2. So I have root 2 into. Let's solve this. So root 2 into, open a bracket, type right in your cos. That's cosine of. Let's now solve this. Look at this now. First things first, 2 times 2 is 4. 4 times pi is 4 pi. So all of this thing here gives you what there? 4 pi. Pi, this one here, pi plus 4 pi gives you what there? 5 pi. So numerator here becomes 5 pi all over what I have here, which is what? 4. So if I solve that, I will have 5 pi all over 4. So cos into 5 pi all over 4 plus I sine as usual. We said repeat the same thing here. That becomes 5 pi over 4. So I have 5 pi all over 4. So we are here. Again, remember that we said pi is equal to what? 180 degrees. So that becomes root 2 into cos. So open a bracket, cos. Since I'm going to be using a round bracket, let me now use a square bracket. So square bracket, cos. 5 pi becomes 5 into what's pi? Pi is 180 all over 4. That's 5 pi over 4. Plus I into sine 5 pi, that's 5 into 180 all over 4. So I have this. All right, let's finish up this. This is equal to root 2 into cos. So I have this as cos 5 times 180. What do I have there? 5. Okay, I'll just punch 5 times 180 divided by 4. So 5 times 180, that will give you 900. 900 divided by 4, that gives you 225. So I have this as cos 225. This plus I sine, the same thing there, 225. So plus I sine 225. I have this. All right, let's solve this question here. What do you have here? Now, if you work on this, this will be equal to root 2 into punch cos 225. If you punch cos 225 correctly, your answer will be equal to minus root 2 over 2. So you can punch that, you have minus root 2 all over 2 as your answer, plus I into, if you punch sine 225, which is this one here, if you punch that, you have your answer as equal to minus root 2 over 2 also. You have minus root 2 all over 2. All right, let's get this done. Of course, from here, root 2 times root 2, we said will give you what there? 2. Bring your minus sign. That becomes what there? Minus 2. All right, so I have this as minus 2 all over denominator there, 2. This cancels this. You have what there? Minus 1. So you have this as minus 1. So this becomes minus 1 plus I into the same thing here. Use root 2 to multiply root 2. That gives you what there? 2. So I have minus 2 all over 2. Just the same working here. And you have your answer as minus 1. Alright, so it becomes I into minus 1. So I have this as minus 1. And that's equal to, so this gives you minus 1. Now, plus times minus gives you minus 1 times I, or I times 1 gives you what there? I. So I have this. We've gotten our third root. Let's now get our final root. So I'll just get this like this. We've gotten our third root. Let's now get our final root. Now for the final root, we now have at k equal to 3. So at k equal to 3, this is the fourth root. Right? our fourth and final root. All right, so for this we have z3. Z3 it's equal to obviously r to power n, 1 over n, please. That becomes 4 r to power 1 over n. So 1 over n is 4 into cosine of pi plus 2 into k. In this case now, k is what there? 3. Becomes 2 into k. That's 3 and then pi all over 4 plus I sine. We'll just say repeat the same thing. So I sine, repeat the same thing. I have pi plus 2 times 3 into what there? Pi all over 4. So we have this. All right, proceeding with this, this is equal to 4 to the power 1 over 4. That gives you root 2 into cos. Let's solve this one here. Again, from the same procedure, 2 times 3 gives you what there? 6. 6 times pi gives you what there? 6 pi. So it becomes pi plus 6 pi. All right, 6 pi. Pi plus 6 pi gives you what there? 7 pi. So all of the numerator there, all of this would give you what there? 7 pi. So it becomes 7 pi all over what I have here, which is what? 4. So that becomes 7 pi over 4. I'll just go take that down. So cosine of 7 pi over 4, 7 pi all over 4 plus I sine, without stressing myself, I'll have the same thing, 7 pi over 4. All right, just repeat it. All right, and that's equal to, let's put in the value of pi. We said pi is what? 180. So first of all, write root 2 into cos 7 pi. Oh, since I'm using a round bracket, let me now use a square bracket here. This into cosine of 7 times pi. Pi is 180. This all over 4. Plus, so plus I sine, repeat the same thing there, 7 pi, that's 180 over what? 4. So we have this. Close this up, and that's equal to, we still have root 2, root 2 into cos. So I'll just get my calculator and punch 7 times 180, and that's about 1260 divided by 4. What you have there is 315. So I have cos 315 plus I sine, the same thing there. Don't stress yourself. Becomes 315. So I have this. And this is equal to root 2 into, now take your calculator there, punch cos 315. If you punch that correctly, your answer gives you root 2 all over 2 plus I. Punch sine 315. So I'll get my calculator, I'll punch sine 315. This will give you minus root 2 all over 2. Alright? Now solve this. What do you have here? Again, root 2 times root 2 gives you 2 all over your denominator here, which is 2. This cancels this. You have what there? 1. So it becomes this into 1 plus I into, from here, root 2 times root 2 gives you what there? 2. So you attach the minus here. This minus comes to the 2, becomes minus 2 all over denominator there, 2. So this cancels this, you have this as what? Minus 1. Alright, so this is this I into minus 1. And that's equal to, from here, this becomes 1 plus times minus is minus. I times 1 is what there? I. So this becomes your fourth root. So if you look at this, you can see that the first root, where is this? Alright, so the first root is what there? 1 plus I. So let me write this there. Therefore, the roots of z to power 4 plus 4 equal to 0. You can say, therefore, the roots of the equation z to power 4 plus 4 equal to 0 are the first thing there you had was what? 1 plus I. Yep, 1 plus I are, you could write this in bracket if you want to. 1 plus I, that's the first one there, comma. Let's get the second roots. The second root there was minus 1 plus I, so open a bracket there, minus 1 plus I. The only reason why I'm opening brackets is just so I can differentiate them, okay? If you write them without bracket, they could look very similar. So just to differentiate them, I'm using a bracket, all right? Next thing you have there is minus 1 minus I. So the next in there, open a bracket, minus 1 minus I. And the final one there, the fourth root there, is 1 minus I. And we have 1 minus I. All right. Now going back to the question there, if you look at the question there, you're asked to prove something. What's your question? Now in the question there, you are asked to show that 1 plus I and 1 minus I are both roots. You're asked to show this and write down the four roots of the equation. All right. So we have to show that 1 plus I and 1 minus I were roots. Now coming back to what we had here, right, so coming back to what we have here, you can see that we have 1 plus I. Look at this here. 1 plus I, which is what we were given, and also 1 minus I. So we found the four roots, and now we want to show that these two are roots. So you can say, and also 1 plus I and 1 minus I and 1 minus I are roots of the equation. Okay, let me write this time now. Of the equation z to power 4 plus 4 equal to 0. So basically, this is how you solve this particular question. Okay. All right, guys. So as usual, if you enjoyed this video, do well to hit the like button, all right, and leave a comment. For your comment, tell us if you enjoyed this video. If you have any question, leave it in the comment section. Also do what to subscribe, right? Subscribe to this channel, hit the bell icon and select all so that you get notified whenever we upload new content. Then finally, share this video to your friends so that they can also learn. Don't forget to visit my website www.jonahemmanuel.com/courses to check out any of the available courses, or www.jonahemmanuel.com/books to check out any of the available books. Do well to register an account to the website and then proceed to get any of the available courses or books. All right. So as usual, thank you and see you in our next class.